Hello class, this is Dr. Scott bringing you the video tutorial to solve Chapter 5, Mathematical Exercise 1. I would normally change some things around to help you solve it so that I'm not doing your homework for you. However, in this case, this is such a basic problem, there's nothing that I can change. The utility function is u equals u parentheses x comma y, which equals x squared y squared, and the typical budget constraint is always going to be m equals p subscript x x plus p subscript y y. Now, there's just nothing for me to substitute. So I'm going to walk you through this exactly as your book walks you through it, starting on page 194. So let's see what we can reveal here. As always, I worked this out ahead of time. Okay. Utility maximization subject to income restraint. This is directly from your book. Again, on page 194. This is the information we need to solve this. So we're going to be using derivatives and the Lagrangian function. There's nothing you need to know about that, just this is what it is. And that's what this little symbol is. I think that's some kind of an L. Never really thought about it. But anyway, so this is the information we need. That's kind of like your answer key. So our first task is to set up the constrained maximization problem and derive the first order conditions. The constrained maximization problem is right in your book. Which is it's just the Lagrangian function. We've substituted x and y in the parentheses because we know that they equal x squared and y squared, and just makes it a little easier to deal with here. You can see. Okay, so next we derive the first order conditions. So the derivative of utility over the derivative of x equals 2xy squared. And that is up here. We're just rearranging things. Minus LP subscript x, and we're setting it to 0. So next we're going to take the variables and arrange them in this exact same format. And again, page 194, 195, and 196 in your book will walk you through this as well. So now we're substituting y into our derivative. And then finally, we substitute the Lagrangian symbol right there. Everything else is pretty much the same. So then here, the next thing we do is we derive the consumer's demand for x and y in terms of the parameters. Now, if there's any way that we could look at this without doing a little bit more math and see which way the line would naturally slope, we would be able to discuss the parameters, but we don't know that, so we've got to do a little bit more work, which again is right in your book. Okay, so we're going to use the first two first order conditions, which means we're working with these. So we know that y over x equals p over p. And you know, although no one comes out and says it to you in this chapter, you know that something over itself is always 1. So we know that y over x equals p over p, which is also 1. But to rearrange this, because y over x equals p over p, we know that y equals p over p times x. So if we look back up here to our budget constraint, we know that m minus px minus p times p over p times x equals 0. Then, when we put this information into the constraint, we get x equals m over 2p, and y equals p over p times m over 2p, which means that it's the same as m over 2p subscript y. So because of this, we've done this step, but because of this, we know that the demand, which we'll call D, is the derivative of x to the power of y over the derivative of p times p over x, which is also equal to negative m over p, or 2p to the squared, times p subscript x over m over 2px. And because we have the negative situation here, instead of 1, now we have negative 1. And finally, we do the same thing with y that we did with x, and we come out with the same number, negative 1. So, since we know that it's negative 1, we know that both of these demand functions slope downward and that they follow the law of demand. So that was what that meant in terms of the parameters. We know that it slopes downward. I know I ran through this pretty fast, as usual, but again, it's right in your book, and this is the actual problem. So watch this as many times as you need to. If you have questions, ask me, but try it first. And math is one of those things, it's kind of like trying to solve a jigsaw puzzle without knowing what it is ahead of time. So there's no way to learn what it is until you actually do it yourself. So I hope you enjoy this. I know that this is a little bit on the confusing side since we don't have actual numbers, but this is just how to set up the problems. We only have a couple of more weeks of actual math problems, and then we'll go more into the theories. So take heart. These are the basics. Again, let me know if you have questions. I'm always happy to help.